The very last step is to calculate a value for the gradient of the maximum gradient, I should say, which is this line here, and the minimum gradient. Now, this has to be done irregardless of the size of your error bars. What do I mean? Okay, if the error bars are very small and you can't draw these maximum lines, that's fine. You have to put a note beneath your graph indicating that fact. If they are visible, you still have to calculate. So either way, you have to get a value for the error on the gradient. How do you do that? Well, we spoke about this in class. We use this formula for a positive slope, okay? And it's this m plus and minus here. It's important to be able to use this and to be able to communicate this in your report. Okay, let's talk. M plus is the maximum slope or gradient. Okay, m minus is the minimum. x1, y1 is your very first data point in your table. X is the x variable, y is the y variable. In this case, x is height, y is average acceleration. So first data point, and this is your last data point. The delta x is the uncertainty in your x variable. In the experiment we just looked at, it's in the height. And delta y is the uncertainty in the y variable. In our case, it's the uncertainty in the average acceleration. So you get your m plus and m minus, and you calculate and put your values in. Then to get the error, okay, it's sort of like random error. You get the difference between the maximum gradient, m plus, and the minimum gradient, okay, and you divide it by 2, and there you have the error on your gradient.